Hello students, I'm Mr. Felix and today I'm welcoming you to mathematics revision, which we shall be looking at a topic called differentiation. This is a topic which is part of a group which we refer collectively to as calculus. Calculus consists of integration and area approximation in addition to differentiation. So at this time we are looking at differentiation and see its application in real life situations and also in various places. So we shall be borrowing knowledge from Form 2, the topic of gradient and straight line, gradient of a straight line. So we remember that gradient of a line is equal to change in y over change in x. If we can sketch the Cartesian plane here, and we have various points So if we have a point A with coordinates 2, 1, so this is the point. So the point A with coordinates 2, 1, and then another point B with coordinates -2, 1. So 1, -2, that's B. 1, -2. You remember we start with the x-axis, then the y-axis. So, and we are asked to find the gradient of the line AB. How do we do it? So we say gradient is equal to change in y coordinates, change in y coordinates over change in x coordinate. So we have these points 2, 1, and then we have 1, -2. So let's calculate the change in y coordinate. This is x, this is y, this is x, this is y. So change in y coordinates, you can start. So the gradient of the line AB can be arrived at by finding the change in y coordinates over the change in x coordinates. We have the coordinates of A as 2, 1 and those of B as 1, -2. So we can start from A to B or from B to A. The problem comes only when you interchange. Maybe you do it. So we are calculating the gradient of the line AB and we are using the formula gradient is change in y coordinate over change in x coordinates. The A coordinates are 2, 1 and then B coordinates are 1, -2. So we start by the y coordinates on the numerator part and then the x coordinate on the denominator side. This is how we do it. So we have, if we start from A, this was A and then this is B, so we can say 1 minus 2 over the coordinates of x. We start from A because that's what we did for the change in y. That's 2 minus 1. When two negatives follow each other, they become a positive. So this is like 1 plus 2. 1 plus 2 is 3. And then we have 2 minus 1, which is 1. So the gradient of the line AB is 3. And that's very simple. This only applies to when we have straight lines. However, you can be getting curves. A curve is a line which is not straight. It changes its gradient. It can be positive, it can be negative depending on where it turns. So let me refer you back again to what we did. In Form 2, we said that if we have a line which slopes from the bottom left to the top right, this has a positive gradient. And then a line which slopes from the top left, the bottom right, this has a negative gradient. And then for a line which is horizontal, it has a gradient of 0. And for a line which is vertical, we said it has a gradient of infinity. Infinity, or it is undefined, which we denote by this letter here, or you say undefined. This knowledge is very key because we shall be using it in working out some problems in this particular topic of differentiation. So now, what is differentiation? That's our main question. Differentiation is a process of finding the gradient function of a curve. I want to draw or sketch a curve here. So I sketch the Cartesian plane. So if I have a curve like this, and then let's say it is cutting at -2, and then here we have 1. So such a curve, if we are asked to find the gradient of a curve, you can see it is changing. There is somewhere it is positive, and then somewhere it is negative. There is a point where it turns, the gradient is 0. So meaning that we cannot be able to calculate the gradient of a curve as a whole or as one number. It will keep on changing from one point to another. There is a concept which you apply. When you want to find the gradient of the line at this point, you draw a tangent to this curve at this point. So you will draw a tangent and then take some points at this particular point here. If I want to find the gradient here, I will also draw a tangent, and then from there I will be able to find the gradient. So meaning the gradient will keep on changing. It will keep on changing. So I draw a line through here and then find the gradient. The same will apply to other points on this particular graph. So that is the process of differentiation. So differentiation is the process of finding what we call gradient function. Gradient function, which we use now to find the gradient at different points. So we have the gradient function, and then we use this gradient function to find the gradient at different points. The gradient function has different names. We can call it the derivative. Derivative. So if you are asked to find the derivative of an equation, so it's the same as finding the gradient function. Or if you are told to differentiate. So these terms are used interchangeably to find the gradient function. Let's consider one case so that we can be able to get it clearly. Differentiation has a formula which we apply so that we can be able to find the correct gradient function. And it is denoted by dy over dx. So if you find something somewhere that you are told to find dy over dx, that's the same as differentiation. This means that you are differentiating y with respect to x. So for a curve, y is equal to x raised power n, dy over dx is equal to n x n minus 1. N x n minus 1. We shall be seeing it as we proceed. So this is the formula that we use. N x n minus 1. That's the formula that we use. For instance, you can be told differentiate y is equal to x squared. We have y is equal to x cubed. We can have y is equal to 5x raised power 4. Let's try doing these examples. So the solution is very simple. Let's identify our n so that from there we can be able to, n here is 2, n here is 3, and here is 4. So in the first case, dy over dx will be equal to n is 2. So we'll put 2, and then x will remain, and then we'll have 2 minus 1. So that now we'll get this as 2 minus 1 is 1. So that's 2x raised power 1. 2x raised power 1 is the same as 2x. And you are done. When we come to the second case, that's b. So y is x cubed. N is 3. So dy over dx is equal to 3x 3 minus 1, which will give us 3x squared. Let's look at the third case. In case 3, we have y is 5x raised power 4. That's case 3. Y is 5x raised power 4. So what we do, we can see we have a number coming before the function, or before x raised power 4. So this number should not be altered. So we only bring the power to multiply it, but we don't interfere with it or ignore it. So we'll say dy over dx is equal to 4 times 5x raised power 4 minus 1. So you can see the 5 still will be retained there. So we will have 4 times 5 is 20. Then x, 4 minus 1 is 3. So we'll have the derivative of 5x raised power 4 as 20x cubed. You can try other ones. Try these ones. So y is equal to x raised power 6. And then we have another one, which is y is equal to 1 over 7 x raised power 7. And then the last one is y is equal to 6x raised power 5. So make sure you follow the formula that I've given. However, in various cases, we do apply the knowledge of indices. For instance, you can be given this function. Let me call it function 7. Y is equal to the cube root of x. How do you do it? Remember what we said in indices, the laws of indices. If you have nth root of a, this is the same as a raised power 1 over n. So that is the same case we apply. We have to express it in this form for us to be able to tackle it. So we will say y is equal to x raised power a third. And now if we are here, we can be able to work it out properly. So dy over dx will be equal to a third x raised power a third minus 1. And what do we get? This is a third x raised power minus 2 over 3. A third minus 1 is minus 2 over 3. And that's the right answer. So I want you to try this one. Let me call it number 8. Y is equal to the 4th root of x. Y is equal to the 4th root of x. Remember this concept and you will get the right answer. That marks the first section of this particular topic. But now in different cases, you can be given a number or an equation which consists of more than one term or of more than one component. For instance, you can be given a term like y is equal to a quadratic equation like x squared plus 2x plus 1. How do you go about it? So here we call this a polynomial. It's called a polynomial. Polynomial, poly means many. So in this case, we have many terms in this particular equation. So how do you differentiate it? you do it by differentiating the individual components or the individual terms of the equation. So you will differentiate x squared, you differentiate 2x, you differentiate 1. And I'm yet to introduce you to another concept which we said in Form 2, that a number raised power 0 is equal to 1. A number raised power 0 is equal to 1. So if you are given y is equal to 1 and you are told to differentiate, how do you do it? So you will say y is equal to x raised power 0. And then from there you will say dy over dx is equal to 0 because our n is 0. X raised power 0 minus 1. Don't even bother yourself because we know a number times 0 is 0. So don't even do it. So the derivative will be 0. So meaning that for a whole number without anything, the derivative is always 0. If we get y is equal to 5, derivative will be 0 because this is the same as 5x raised power 0. When you multiply this 0 by 5, so you'll get that dy over dx will be equal to 0. So make sure you understand that one even as we do this. So we were looking at finding the derivative of a polynomial. So, and as I told you, you find the derivative of each of the terms making up that particular polynomial. So we will start. And at this point, we should be grasping that concept very fast because we have done it before. We'll say dy over dx will be equal to, here we'll have 2x. Very quickly, because 2 minus 1 is 1. 2 minus 1 is 1, and then these 2 will come here. So nx n minus 1. Remember, that's the formula. dy is n, dy over dx is nx n minus 1. So just do it very quickly. That's 2x. Plus, this is 2x. So 2x is the same as 2x raised power 1. So 2x raised power 1. So this 1 will subtract 1 and then it will multiply here 1. So what shall we get? This will be x raised power 0, which is 1. So it means x will disappear from that particular number and the derivative will be 2. And then, as I told you, a whole number will have a derivative of 0. Even don't bother yourself going to it. Derivative of 1 is 0. So, and that is the derivative of that particular equation. That's case 1. Case 2, we can find an equation like this. Y is equal to x cubed plus 2x squared minus 4x minus 8. Very quickly, let's do our dy over dx. It is 3x, you less the power by 1, so that's 3x squared minus plus, that is 2 times 2 is 4, then you less the power by 1, that will be 4x, then this is minus 4, so 1 minus 1 is 0, and 1 times minus 4 is minus 4, so it will remain to be 4. And a whole number will have a derivative of 0. So this is the derivative of that particular equation. Let's do one more. So you can be given an equation like this. Y is equal to x cubed minus 3x minus 4. This is very simple. So dy over dx will be equal to 3x squared minus 3. By now you should be getting it very easily because you have the concept with you. So I'm giving you some work to go and try at your own convenient time. Differentiate y is equal to x raised power 5 plus 4x raised power 4 plus 3x cubed plus 2x squared plus x plus 1. So work out that. Then the second one is y is equal to the cube root of x squared plus 2x minus 1. And then the third one is y is equal to x raised power 8 plus 7x raised power 6 plus 2. So make sure you do that one so that you can check whether you understood. In some cases, you may get that the equation is not linear. You get the equation is nonlinear. When we talk about an equation which is not linear, we mean that in this case it's not a straight line, or it consists of two sides. It can contain the numerator and the denominator. For instance, you may be told differentiate y is equal to x squared plus 2x plus 1 over x plus 1. Now, how will you deal with this one? So the first thing you need to do, make this to be a linear equation. How do you do it? Factorize. Factorize the numerator part, and then as you proceed, you will be able to see that there is a part which will cancel out with the numerator part, and then you differentiate after that process. In this case, we have a quadratic equation whereby we remember the general quadratic expression ax squared plus bx plus c. So we have to factorize by looking at two numbers whose sum is b, and then product is AC. So let's look for two numbers. Sum is 2, product is 1. So what are these two numbers whose sum is 2 and product is 1? These numbers very quickly are 1 and 1. When you add 1 and 1, you get 2. When you multiply 1 by 1, you get 1. So we will factorize by splitting the middle term, that's b. So we'll say, let's factorize. So x squared plus 2x plus 1 will give us, now we factorize, we split this, it will give us x squared plus, now this will be 1 and 1. 1x, we don't write 1x, we'll write x. So plus x, this gives us 2x plus 1, which will give us x. Let's factorize in pairs. So x is common into x plus 1, plus what is common here is 1 into x plus 1. So we get x plus 1, x plus 1. And then from there now, come and have the numerator or the denominator. So y is equal to x plus 1 over x plus 1. What do you see? You cancel out those ones which are similar. So these will cancel with that. So y will be x plus 1. Then now proceed to differentiate. So dy over dx will be equal to, this is x. The power is 1. So it will be 1 because this is like x raised power 1. 1 minus 1 is 0. Number is x raised power 0 is 1. So that is the derivative. I hope you are following to that point. I'm giving you two of them so that you attempt them and see whether you are able to work them out correctly even as we conclude our session of today. So differentiate y is equal to 4x squared plus 4x plus 1 over 2x plus 1. Second case is y is equal to x squared minus 5x plus 6 all over x minus 2. So make sure, remember what we said, you have to factorize first before differentiating. Those are some of the concepts that you need, as we have said. So in brief, we have learned today that differentiation is the process of finding the gradient function of a curve by using the formula dy over dx is equal to nx raised power n minus 1. So for y is equal to x raised power n, dy over dx, as we say, it is equal to n x n minus 1. That's what we did when we said y is x cubed. So we'll say dy over dx is equal to 3x raised power 2, 3 minus 1. We have also said that indices are very important. If you get the sixth root of a number, you are told to find the derivative of the sixth root. Remember what we said, you must first express this number in the form of, if we have nth root of x is equal to x raised power 1 over n. So you have to say this is y is x raised power 1 over 6 before differentiating, so that you get dy over dx is equal to 1 over 6 x raised power negative 5 over 6, and then that's the correct answer. So, and the last concept is the one which involves factorization, which we have done. I hope that you have followed, and I'm encouraging you to go and do more practice, especially using the Kcse Made Familiar book and also solving problems, because it has more examples. In case of a question, you are free to ask through our platform. Until next time, I wish you the best.